So today, I'll be teaching you guys a really cool rule that comes really handy with your algebra stuff when solving math problems, and it's called the AM-GM inequality. So let's first understand what this AM and GM stand for, and let's look at AM first. So AM stands for the arithmetic mean. The arithmetic mean. And the arithmetic mean is the sum of all the numbers divided by how many numbers there are. So if we have two numbers, a1 and a2, then the arithmetic mean of these two numbers would be a1 plus a2 divided by 2, as there are two numbers. And if we have an n number of numbers, a1, a2, all the way up to an, then the arithmetic mean of these numbers would be a1 plus a2 plus all the way up to an divided by n, as there are an n number of numbers. So now we know what the AM is. Now let's look at the GM. So the GM stands for the geometric mean. So the geometric mean is the product of all the numbers to the root of how many numbers there are. So if we have two numbers, a1 and a2, then the geometric mean of these two numbers would be a1 times a2 to the root of 2, as there are two numbers, so the square root. Then the geometric mean, what is the geometric mean of an n number of numbers? So it will be a1, so these n number of numbers will be a1, a2, all the way up to an, and the geometric mean of these numbers will be a1 times a2 times all the way up to an to the root of n. So now we have a basic understanding of what an arithmetic mean is and a geometric mean is. So now we can look at what the AM-GM inequality is. So if we have two non-negative real numbers, a and b, then the arithmetic mean of these two numbers, will be a plus b divided by 2. And the geometric mean will be the square root of a times b. Now I will introduce to you the AM-GM inequality. So the AM-GM inequality states that for any set of non-negative real numbers, the arithmetic mean is always larger than or equal to the geometric mean. But why? Now let's try to prove the AM-GM inequality for two non-negative real numbers. So proving this inequality. So let's try to prove this. So multiply 2 on both sides to get that 2. So this becomes a plus b, and this becomes 2 times ab, 2 times root ab, and subtract 2 root ab on both sides, and this side becomes 0. And if we factorize this, it becomes root a minus root b squared is larger than or equal to 0. So we know that a square is always larger than or equal to 0. So this is true. And therefore, this is true. So the AM-GM inequality for two non-negative real numbers is true. But surprisingly, this AM-GM inequality not only works for only two non-negative real numbers, but it works for any number of non-negative real numbers. So let's erase this first to get more space. So let's try three non-negative real numbers, a1, a2, and a3. So the arithmetic mean of these three numbers would be a1 plus a2 plus a3 divided by 3. And the geometric mean would be a1 times a2 times a3 cube rooted. And the AM-GM inequality states that the arithmetic mean is larger than or equal to the geometric mean. And it holds true for any three non-negative real numbers. Now what if we have an n number of non-negative real numbers? So a1, a2, all the way up to an. So the arithmetic mean is a1 plus a2 plus all the way up to an divided by n, change to blue. And the geometric mean is a1 times a2 times all the way up to an to the root of n. And the AM-GM inequality states that the arithmetic mean is always larger than or equal to the geometric mean for any set of non-negative real numbers. And that is our general formula for the AM-GM inequality. So now we have a fundamental understanding of what the AM-GM inequality is. But how is it useful in math problems? So let's try a really simple math problem that uses this rule really directly. So let's erase this first to get space. Okay, here's the problem. If we have two non-negative real numbers a and b, and we know that a plus b is equal to 24, then what is the maximum value of a times b? So this AM-GM inequality, the formula for the AM-GM inequality is an inequality, so it shows the maximum or minimum value for a specific value. So this rule is typically used in problems that ask for the maximum or minimum value of certain unknowns. So let's try using the AM-GM inequality with a and b to find the maximum value of a times b. So what is the arithmetic mean of a and b? Well, it is, let's change it to red, it is a plus b divided by 2. And the geometric mean is the square root of AB. And the arithmetic mean is always larger than or equal to the geometric mean, as the AM-GM inequality holds. So we know what a plus b is, though. It is 24, as the question says. So we can substitute that in. So substitute that in. And 24 divided by 2 is equal to 12. And that is larger than or equal to the square root of AB. The square root of AB. And square both sides. 12 squared is 144. Square root of AB squared is the root thing cancels out and becomes AB. So we know from this that AB is smaller than or equal to 144, so its maximum value is 144. So that is our answer. So now we have our basic understanding of what the AM-GM inequality is and how it can be used in math problems. So hope you understood, hope you learned a lot from this video, and see you in the next video.